Hello, welcome to this video. So this problem is about quadratics. Okay, so as you can see, quadratics, so degree 2. Okay, so it's a quadratic function. Okay, so that's why we have a degree 2, okay, in variable x here. So function is a graph, so that's why in part A, part A. Okay, so that's the graph of fx cast the x-axis. So of course here for cast the x-axis, okay, we try to put y to 0 or simply, okay, so we just try to consider the delta, okay, of the quadratic expression, okay, of the function. So that would be 4kb squared minus 4ac. So 8 times 3, so negative 24k squared, 8 times 5, so negative 40. So combining like terms, okay, so that would be negative 8k squared minus 40. And then here you can see, first of all, okay, so maybe I'll try to explain a little bit. So k squared would be non-negative, okay, for all k. Okay, so and after you try to multiply both sides by negative x, so negative x squared would be less than or equal to 0. And then if you try to subtract both sides to 40, so that would be less than or equal to negative 40. And then negative 40 is less than 0, so that's why delta. Okay, so that's why delta less than 0. Okay, but of course, okay, the green workings, okay, you do not have to write in your scripts, okay, explicitly. So here all you need to write, okay, so just delta less than 0. So that's why okay, so part A, so it does not cut the x-axis. It here, okay, refers to the graph of y equals fx. Done. So that's part A. Any problem? B. Okay, so using the method of computing square expressed in terms of k. So here, so for part B, so y equals fx, so y equals 2x squared minus 4kx plus 3k squared plus 5. Here, so since the coefficient of x squared is 2, so that's why we try to take out 2, okay, from the first two terms. So in particular, so that would be just the x squared term and x term. So here, constant term is not very important, so just put it aside. And then for the coefficient of x, so there will be negative 2k. We try to halve it, so there will be negative k, and then try to square it, so that's why plus k squared minus k squared. And then here, we just need the first three terms. So that's why expel the fourth term out of the bracket. But here, be careful. So negative times 2, so that's why negative 2 here. Be careful. And then after that, so that will be 2, and then bracket x minus k all square, plus 2k squared plus 3k squared, so that will be plus k squared, and then plus 5. Okay, so and then by using the method computing square or this process, okay, we can rewrite the quadratic function originally in general form into its corresponding vertex form. So of course, okay, now, okay, we can write the required vertex equals k squared plus 5. Okay, so part C. So in the same coordinate system, let S and T be moving points on the graph of y equals fx and y equals 2 minus fx respectively. Denote the origin by O, and then someone claims that when S and T are nearest to each other. Okay. Now first of all, okay, so since okay we have the second graph, so y equals 2 minus fx. Okay, so first of all, okay, in part C, we try to denote, okay, so the vertex of the graph y equals 2 minus fx. So I try to denote this vertex by G. And then from the above, okay, so from part B, okay, so we have done the computing square. So, or fx after doing the computing square. So, okay, so fx would be 2x minus k all square plus k square plus 5. So 2 minus fx, so it will be 2 minus the above expression. So minus, okay, so this minus sign times 2. So that's why, okay, we can get minus 2 x minus k all square. So and then that would be plus minus it. Oh, okay, right. And then that would be minus k squared minus 5 and plus 2. So that's my minus 3. So that's why, okay, from this vertex form, so y equals, so g will equals to k and then negative k squared minus 3. And then there will be the vertex of the second graph. Okay, the vertex of the second graph. And then you can see that with y equals 2 minus fx, okay, so you can see that the leading coefficient, the coefficient of x squared is negative. So that's why here, okay, so the green graph, okay, will be opening downwards. Okay, so with the vertex k and the negative k squared plus 3. Okay, so and then after that, and then the original graph, so that will be y equals fx. So you can see that this graph, okay, will be opening upwards. Okay, so with the vertex find in B, so that will be k squared plus 5. Okay, so you may ask, oh, Mr. Chen, okay, why you can directly flip, okay, the green graph, okay, upward, okay, to obtain the blue graph. Okay, so here you can see that, the x coordinates are the same. So when the x coordinates are the same, okay, so the two vertices, okay, so the line joining the two vertices, okay, will be vertical, So now here, okay, so S and T are actually the moving points, right? So S and T are moving points on the blue graph, okay, and also the blue graph and the green graph respectively. Okay, so when S and T, okay, are nearest to each other, so you can see that S and T will be simply here. Okay, so S and T, maybe using blue or green. So this is S, and then this is T. Okay, because okay, S and T, okay, are nearest to each other, so it seems that, okay, here, okay, the distance, okay, will be minimized. Okay, and then denote the origin by O. Okay, maybe O somewhere here. Okay, so and then the circumcenter of OST. Okay, OST. So the circumcenter of triangle OST, okay, would be lies on the x-axis. Okay, so first of all, if this is the origin, the x-axis is here. Okay. So that's why here, okay, so maybe we try to enlarge this graph. Okay, can I just enlarge this part? But never mind. Oh no, it's okay. So you can see that, okay, when, first of all, maybe we try to put that down first. So when S and T are nearest to each other, S becomes the vertex of the blue graph, and then T, okay, becomes the vertex of the green graph. Okay, but here you can see in this case, now note that ST is vertical. Okay, so that's why here the perpendicular bisector, okay, because circumcenter, okay, will be the point of intersection. Okay, so that will be the point of intersection of the three perpendicular bisectors. Okay, so that's why, okay, if ST is vertical, ST refers to this line. If this is vertical, so the corresponding perpendicular bisectors, okay, would be a horizontal line. Okay, so in that case, okay, we just try to look at the y coordinate, okay, of the circumcenter. Okay, so maybe here, okay, I try to redraw this graph. Okay, so we only have 3 points. So the first point, and then the second point may not be isosceles, like this. So this is k squared plus 5, and this, okay, will be k negative k squared minus 3, and then this is 0, 0. Don't forget, okay, this one is the x-axis, green line, and then this is ST, you can see, will be vertical. So of course, okay, already, okay, you can see that, wow, we need to draw the perpendicular bisectors. Okay, so the perpendicular bisector of ST, so will be here. Okay, because, okay, you need to be the midpoint. And then the circumcenter will also be lying on the one, of course, okay, the circumcenter, okay, is the point of intersection of all the three perpendicular bisectors. So of course, okay, the circumcenter must lie on one of the perpendicular bisectors. Okay, so you can see that, okay, we try to find the circumcenter. Okay, in particular, okay, we try to look at the y coordinates. So of course, the y coordinates, okay, will be just k squared plus 5, and then plus negative k squared minus 3, and then the whole thing over 2. And then you can see, well, k squared cancel with negative k squared. Okay. And then this part cancel with this part. And then 5 minus 3, so that will be 2. So that's why the y coordinate is 1. And then it does not equals to 0. Okay, so that's why here, okay, just zoom out a little bit. So plus not equals 0. Okay, so that's why you can see, so the circumcenter does not mount the x-axis because the y-coordinate of the circumcenter is not 0, okay, which is independent of k. So that's why you can see became insecurate. So this finishes this problem. Okay, so and then thank you for watching.